Hey, Phil, how are you?
Good.
Good.
Great.
Hey, good morning.
Meet Echo.
Yeah, I'm gonna give it a shot.
It's working better than SharePoint.
You mean WebEx?
Yeah, we've been using WebEx. WebEx works well. The Skim group was using SharePoint because
Oh,
Is
Pam
that
Dingle was
Teams?
organizing. I
I
think
see.
that's the Microsoft Teams thing, but
Yeah.
it gets stuck between login and somewhere else.
I see.
Yeah, yeah, I got to use that with the city of Seattle was using it for a bit, and then they switched to WebEx early on in the pandemic.
Yeah.
Which tells you something about the experience there.
I think my complaint was I couldn't tell which component failed, whether it was authentication or the app or the redirect or something. I just got a mysterious, was unable to to connect you. Oh, okay.
I shared a link to the notes for this meeting, so please go ahead and add your name to that list. Are you guys able to access it? I don't see anyone there yet. There you go. I see Annabelle.
Oh,
It looks like
there
the
it is.
agenda link as entered into Meet Echo is broken. I'm guessing $description is supposed to be replaced by something else.
I got in.
Can you guys hear me?
Yep.
Yes, we can hear you, Hannes.
Hi, hi everyone.
Annabelle, can you say it again? Like, what's that?
Oh, if you under meeting materials in Meet Echo, there's agenda and slides. The agenda section contains a link, but it looks like it's I don't know if it was just a copy pasted stock link or what, but it doesn't work.
I see.
And the topic is IETF-106 as well.
Say that again, sorry.
The topic set on Meet Echo is set to OAuth at IETF-106. So I think Annabelle's right. I think that there was just some default carryover when this Meet Echo was created.
Yeah, okay. Yeah, well, we'll try to. This is my first time doing this, so I probably messed up something there. So we'll see. Okay, we are 3 minutes past. I'm assuming it's recording. I don't have any control over the recording. It says recording here. So let's maybe get going. And again, I request that people go and add your name to the list. I see only 3 people added their name, so please go. I just shared that link in the chat there. So can you see that, the link, guys? Or do I have to share it to everyone every time somebody joins?
Yes, it's there.
Okay. Okay, so please go add your name to the list, and let's get going. Let me share the slides here. Okay. Trying to figure out how to share now. Presentation view. And how do I share? Oh my God. Anybody knows how to share with this tool? Hannes, do you know? I don't see any. Share the screen.
So I just requested sharing. Okay. You guys should be able to see my screen.
Yeah. How did you get that? Like where
So I'm just in the MeetEcho web thing, and it's in the same control box where you turn on and off your mic.
Yeah, I see it. I see it. Okay, perfect.
Yep.
Thank you. Let me try that, and then we can.
Yep. Go ahead.
I'll hand it. Okay, I'm assuming you can see my screen now.
Yes, that's coming through now. Thanks.
Okay, awesome. Thank you. Thanks, Justin. Appreciate that. Okay, let's get going. First, as a reminder, this is the not well. This applies here. This is today's meeting will be focused on HTTP message signing. We still have one more meeting to schedule for OAuth 2.1. That will be coming later. A reminder, like about a few updates about the work on the IETF group in this work group. So the security BCP passed the work group last call, and Hannes will be working on the Shepherd write-up soon, hopefully. And the authorization server issued identifier in authorization response draft is we're trying to kind of move this forward. So please go and review that document. And even if you don't have any concern, just say that, explicitly say that on the list, so we know at least you've reviewed that document and you have no concern. Otherwise, we'll not be able to push it forward, right? So appreciate if people can review it and provide some feedback. That's all I have. Any comments, questions about this? Okay, I'm gonna then stop sharing now and hand it to Justin. Justin, up to you.
Okay, sounds good. Should be. I think one of you guys needs to approve the screen share request. There we go.
Got it. Yeah.
Awesome. All right. And hi, everybody. And just a note to the chairs, once I go into presentation mode, I can't see the chat. So just, feel free to interrupt,
I'll monitor.
All right. So can you see just the title slide now?
Yes.
All right. Perfect. Can never tell if this is sharing the right thing. Okay. So, hi everybody. Today I am digging up an old topic, and that is HTTP message signatures, and how we can use them with OAuth 2. Because since we started looking at this a long time ago, a few things have changed. But just a bit of history for those of you. Most of you probably remember, but OAuth 1.0, all of the messages were signed. And they were generally shared keys, although there was this weird googly way to do RSA keys, although nobody paid much attention to that. OAuth 2.0 originally had a bearer token and a MAC token, but that got dropped on the floor by the previous editor and left to kind of languish. It did eventually, the concept there did eventually get picked up into a more general proof of possession architecture and key distribution set of documents, and part of that suite was the signed HTTP request suite, which I was the editor for, largely because I'm the one who who made the mistake of volunteering to actually try and solve this, because how hard could it be? And it turns out really hard. If you go look at the now long since expired signed HTTP request draft, there was a lot of bits to it. Now, the reason that I picked it up was that there were some existing HTTP signing drafts out there, but they weren't really directly useful for our purposes. So the Cabbage draft, and I think Yaskin had a draft at that point, or he at least did eventually within this time frame. None of those had workgroup support. There was limited coverage of the HTTP message, and most importantly, very limited flexibility about how and what you could sign and how to actually use the thing. It had a very specific use case. All of them had a very specific use case that they were coming from, and they didn't have the machines of a working group to actually kind of push that into general functionality. So again, I was like, how hard could it be to actually make one of these? It turns out it was really hard. The way that the old draft works is that you kind of smush all your headers together and hash that, mash the parts of the query together and hash that, and you hash the body, and you throw in you repeat a couple of extra variables from the HTTP message, things like access tokens and timestamps and the method in URI and maybe some other stuff. It's extremely drafty and hand wavy, but you kind of wrap everything there up into a JWS and then you send that. So it is a detached HTTP signature, but the signature itself is wrapped entirely in a Jose JWS object with all of the bits replicated and kind of stuffed inside of the JWS object. And a lot has changed since that work was picked up and subsequently kind of left by the working group. Specifically now, Annabelle, and I think I saw her on the call, right? Yeah, she's here. Annabelle and I have picked up the editor's pen for a new draft in the HTTP working group. And this is important. This is an actual part of the HTTP working group that takes input from a bunch of the different community drafts. Most of the structure is from the Cabbage draft, some of it from this Oauth draft, some of it from the Yaskin drafts, and some other stuff that we found floating around out there, and decided to make an actual official HTTP detached signature draft that is designed to be profiled and flexible in the ways that we know that people were profiling and applying this thing to begin with. Now, the way that this draft works is that you choose your covered content and crypto parameters, and then there's a normalization process for the HTTP message. And both the sender and the receiver go through the same normalization process. So you figure out what content you're signing, pull that out, format it in a very specific way. That gives you your signature input string. Then the easy part is kind of the security crypto part. You take that input string of the normalized HTTP message, run that through a crypto function, and that gives you a blob of bytes. And then you send both that signature output and the parameters that you use to create it as structured HTTP headers. Now, I want to point out there's a buried bit in this last point. There is, in fact, a new HTTP RFC out there called structured headers, which means that you could do things like...
Justin,
yes,
can you hear us?
Yes.
Hannes, you had a question?
I was just wondering, the normalization, is that a different word for, or the same as canonicalization? Because that was something we used as a term in previous discussions. Is that the same or a different?
I'm using them interchangeably. I know that there are some subtle differences out there. The thing is, from the view of the HTTP message group, HTTP is now defined in terms of semantic objects, which have serializations across the different HTTP versions. And so it is more canonicalization. And functionally, the way most developers are going to be implementing it, they're going to be canonicalizing strings. But it does really get into the semantic normalization kind of territory.
Yeah. Because
And if you want to get really confused about those differences, go read the HTTP Digest draft, which I'll talk about in a bit.
No, I was just trying to see like how the differences evolved over time, because in OAuth 1.0 we had this also a canonicalization draft, which developers got a little bit upset about. And then later we moved from that away, which was sort of this completely wrapping it up in JSON, basically replicating all the parameters, which people liked a lot. But now it seems that we are going back to where we started. Is that fair to say, or do I miss that point?
There's some subtlety that you're missing there. So one of them is that in the OAuth draft, we copied some of the parameters, but there was in fact canonicalization of components, specifically headers, were not copied directly. And query parameters were allowed to be signed in a detached fashion. So you're not wrapping up the entire message in JWS, and I'll get into that specific point towards the end of the presentation as well. So the OAuth draft was kind of the worst of both worlds, in that it did have some canonicalization requirements to it, but it also tried to use this encapsulating signature method in Jose. So it was a weird chimera of the two. Yeah, and as far as the general construct of a detached HTTP message signature, there are a lot of people who don't want to use this kind of mechanism because of the need to do processing on the HTTP message itself. They would just rather wrap everything up in an object and send it. And to them, I say, go for it. Have a good time. There are huge drawbacks for doing that as well, though. And with this draft, and especially with it being positioned in the HTTP message group, the HTTP working group, we can, I think, do a much better job of explaining what that trade-off space is for somebody going and looking at this draft versus, say, doing everything over an XML DSIG document with all of your parameters inside, which is, as we know, how SOAP works. And it is a trade-off in the design space.
Justin, if I can add one thing on that too.
Yes, please go ahead.
Yeah, part of that, I think it comes down fundamentally to, how are you structuring your messages, your API over HTTP, and if you have an API, especially if you're working in Greenfield and you just want to put everything into a JSON object or a XML object and send that as your body and yay, you're done. That works really well, and if you're building a new API, you could do that. It's great. But then there's this whole universe of stuff that's been built on HTTP and puts important things in headers, important things in query strings, important things in the body, and all over the place. And so one of the goals with HTTP message signing is really to provide a message level kind of authenticity check that is flexible enough to cope with the wide variety of changes that are permitted to HTTP messages as they pass through proxies and whatnot. So.
Yeah, and that's an important thing to note as well, is that when you're using HTTP in the real world, there's a lot of different pieces that touch it. So assuming that you will have component level integrity over the entire message is largely a losing game, which is why HTTP message signature draft has gone in the direction that it has. And I think it'll be more clear once I can sort of talk through an example of how it works, and then we can discuss how that applies in kind of the larger scope of things. All right.
Yeah, keep going.
All right. So a point that I wanted to make on this slide before moving on, because it's important to know, is that there is a new RFC. It was just published as an RFC in February of this year, called Structured HTTP structured HTTP message fields, or field values, technically is the term, but as we would all know them, they would be structured HTTP headers. This means that there's now a standardized way to do things like dictionaries and lists and byte arrays and all of that kind of stuff in HTTP headers. So the syntax that we're going to be using in a lot of places here is not something that Annabelle and I invented, which was how we used to have to deal with a lot of things in HTTP headers. This is all part of that spec, and a lot of the HTTP group, a lot of new extension specs are moving towards using these definitions. All right. So I'm going to walk through an example now of signing an HTTP message so you guys can get a feel for how this works. And then we're going to talk about how this applies to OAuth and some of the questions around it, including the questions that Hannes started to raise about, why do detached signatures at all? So this is our HTTP message. It's a simple post request. I will point out that the message signing can be used for both requests and responses. I'm going to focus in all of these demonstrations here on the request for simplicity. We're going to sign the following parts. So you should be able to see my mouse cursor. We're going to sign this request portion. So we've got a post and we've got a URL. We've got a host header. We've got a date header. We've got a content type. And we're deciding not to sign the content length of the body in this particular request. The important thing here is that there can be other headers that get added by intermediaries like via or forwarded for, or the client cert parameter from Brian's proposed extension. And the signer can choose to sign all of the parts of the message that it believes will make it intact to the endpoint. So if you know that you have part of your application that's got to mess with part of this for whatever reason, you can choose not to sign that piece. You can also choose to sign it, but add another signature, as we'll talk about later. All right, so I'm going to take this HTTP message, and then we create this canonicalized and or normalized, depending on which side you're looking from, signature-based string. Now, this string is a very, very simple format. Every piece of covered content gets its own line. So we've got the request target here, which, I realize there's a typo there. So none of these request signatures will actually validate because there's supposed to be an opening quote there, but we'll pretend that's there. The @request target means that, I've got my verb, I've got the URL that I'm going to, and the host header with the header value, the date header with the header value, same with content type. And then finally, this special @signature params value, which has the list of all of the covered content that is signed. So request target, host, date, and content type. And then any additional parameters and variables that the signer needs to add in order for the verifier to understand it. So we've got the created timestamp and a key identifier in this particular example. You take this and run it through the appropriate key signing algorithm, or the crypto algorithm, and you end up with a blob of bytes. And this is here in base 64. No big surprise here. Then you add these to the HTTP message. So you've already got your HTTP message, and you've kind of run it through this utility that says, go sign these parts of it, and you get back values that you can put into a couple of new headers. So there's the signature input header, which has that list of covered content, which again, a typo, that should have the request parameters. Sorry, it was this, as you guys all know, meeting was scheduled very quickly. So we've got the signature input here and the signature value itself. Structured headers gives us a way to say, like, we've got this, we've got a list of values that have a set of parameters that's associated with that list. And this syntax is saying that we have a sequence of bytes that is encoded in base 64. What's important here is that from the definition of the specs perspective, this is a byte array. This is not a string that has been encoded in a particular flavor of base 64, because all of that is defined by HTTP structured headers. As you guys can hopefully see, it is a very deterministic and very straightforward way to apply a signature. Now, when I'm verifying a signature, I'm going to get these two values, and I'm going to pluck them off and say, oh, these are the bits that were covered in the signature. And I've got a timestamp of when this was created. There's also an expires field if you want to use it. There's a nonce field if you want to use it, and you can extend these as well. And I've got a key identifier that's going to tell me as the verifier, okay, which key should I test this against, and probably which algorithm that is associated with that key, although there is also an algorithm field if you need runtime agility there. And then I've got the signature bytes. So I'm going to pluck out the signature bytes. I'm going to now recreate that signature base string using the same algorithm that the signer did on only the parts of the message that the signer says that they signed. And I'm going to add as my last line there, this line, which is specifically the bits that the signer said that they signed. So all of this gets covered by the signature, and I can then validate it based on the key. All right. So before I move on to how this applies to OAuth, any basic questions about how HTTP message signing works? Keeping in mind that this conversation today is not about the structure of HTTP message signing, because that is happening in the HTTP working group. All right.
No, sorry. Can you, Justin, do I understand correctly that you're using the structured headers to encode the output, the result of this stuff, but you're not relying on structured headers for the input? You can sign old-fashioned HTTP headers. Is that correct?
Yes, that is absolutely correct. So you can sign headers, and for the most part, developers will be able to get away with doing a somewhat lazy thing of just taking the string and signing it. Like, you guys all know me. You know that I am, first and foremost an engineer of these things. All the pretty semantics aside, we need to be able to hand this to a developer and have them get it right. It's especially important for a security draft. So there are some considerations on how you handle things like multiple repeated headers, or if you've got headers and trailers, like how do you mash those kinds of things together. For the inputs, though, here, let me back up to that slide. For the inputs, though, like, host, date, and content type, those are all just plain string headers. Each has their own internal format, and we're just saying, take the value that you're putting into that header, and that is what you put here. So yes, absolutely, 100% can sign any header with any valid header format, and put it into this string. There is, however, an additional consideration that if you do have a structured header, the signing spec allows you to be a little bit more precise about that. You can require the structured value to go through a strict normalization process, or you could sign a sub piece of it. There's other stuff that you can do with that if you have a structured header. But the default, without any other flags or anything on it, is just take the header value.
So Justin, so you're saying you're taking the values only, not the header itself, not the, like, if you go back, it's not host example.com,
Correct.
only example.com. Okay.
Yep, correct. So this left-hand value is actually constructed as part of the signature-based string algorithm. And specifically, this actually does make use of the structured headers serialization rules. So you take the header name, lowercase it, because headers are not case sensitive in HTTP, and then you serialize it as a structured field string value with optional parameters, I think is what it is. I'd have to check the AVNF. But that's why it gets quotes around it. That's why it's lowercase and all of that. You do not just take the header value, just the header line as printed out. You do have to construct it with this identifier field and the separator, and then the header value itself.
Okay.
One advantage of that approach is it is more resilient to variations across HTTP versions as far as how these things get represented on the wire.
Yep.
how you send an HTTP 2 header versus how you send an HTTP 1.1 header looks kind of different. So just saying, like, take the header line and put it in here doesn't necessarily work all that well.
Yeah, absolutely. The other thing that it allows us to do, and I wasn't getting into the details here in this demo, is that all of these values, there's a syntax for adding parameters, which you can see in this value here. So you can have keyed parameters for the left-hand side, which is how you end up being able to sign a subpart of a structured header. Or Annabelle and I have talked about, I think we've got an issue filed for maybe doing something with request target where you're only signing the verb and path like Depop does, or some other limitation like that. It gives you a lot of flexibility in defining how what you want to signal to the other side. And those values with all of their parameters end up in this string down here. So let's say we had at request target and it was verb only equals true or whatever, then it would show up down here as at request target semicolon verb only equals true, or whatever the appropriate values and formats are. And that's the string that ends up in the header that you actually send to the verifier. So this gives us a way to pass a lot of information between the signer and the verifier without relying on this entire message as a string to survive intact.
And with the HTTP structured header syntax, we're reusing that all over the place here, which simplifies the amount of syntax we're inventing, simplifies the amount of syntax that implementers have to deal with, and just provides a lot of nice things like this out of the box.
Yeah, exactly. Great question though. And I will take half a second here to fully credit Annabelle for the structured header idea, because when we first went down this, I thought she was nuts with this idea. But quite frankly, having built this on a number of platforms now, it's really nice. You get a lot of really good stuff from this, and I'm excited to see structured headers in other stuff. In addition to how we were able to use it here, it makes dealing with the type of like very precise definitions you need for a security protocol much easier. It gives you a language for that.
Especially when you consider that, like, in the not too distant future, structured field parsing is just going to be part of HTTP libraries. It's just going to be there. Yeah.
And we're already seeing libraries on a number of different platforms. I've built out this the signing stuff in Python and in Java right now, and I didn't actually write a structured field library for either of those, which was pretty awesome. That those are already starting to pop up, and they'll start to just be eventually built in. Okay, so this is a thing that's happening in the HTTP working group. If you're interested in making that better, go hang out in the HTTP working group. Annabelle and I are pushing this forward, and it's going well. So how do we take and apply this whole thing to OAuth 2? So quite frankly, this is the kind of draft that I wish that we had way back in the day when I wrote the OAuth signed HTTP draft that's out there and expired right now. Because like the features that we're building into this message draft are exactly the kinds of things that we're missing from the community drafts that were much more sort of, point solution based. The Cabbage draft started its life as an AWS identifier, which uses share keys and key derivation functions and all of these other assumptions that go into it. And it fits great into that little niche, but prying it out of that, as the Cabbage drafts tried to do, ended up being much more difficult. What we've got now, I think we can actually leverage. So my proposal is that we base the OAuth message signing draft on this, which is on its way to be an RFC. So we create a new token type. We could name it POP, which is what the old draft does. We could name it HTTP SIG if we wanted to, and that would especially help it be separate from Depop, but more on in relation to Depop in just a minute, because I am thinking about that. And we set up requirements for how HTTP message signatures get used. One of the things about the new draft, the new HTTP draft, is that it enumerates all of the things that you have to define in order to use this in an application, including defining what your minimum covered content is. What your minimum presentation of headers like. So for example, we would say you have to just use the signature and signature input and authorization headers all together, and you're required to cover the authorization header. And one of the benefits that OAuth has is that the key and algorithm, which is a potential place for confusion and potentially security threats if somebody does algorithm substitution or key substitution. We've got this whole notion of a client in OAuth, which can have registered keys, or they can have generated and negotiated keys, like we were talking about in the OAuth POP key distribution draft way back in the day. So maybe we can dust that off, figure out how to get that going and things like that. And all of this stuff can be communicated down to the RS using JOTS and introspection, much like we're already doing that with MTLS, and much like Depop is communicating how to do it there. So this is what an OAuth signed request might look like. Quite simply, we've got the authorization header, which contains the token value, and we sign the message and sign the authorization header. That's the core. That's what we need to do. Now, we might say define a client ID field and include that there, or we might not. That's one of the things that this working group is going to have to kind of figure out, right? So a couple of features that were in the old OAuth draft that are not in this one. You can't partially sign query parameters. That was something that I came up with in the old OAuth draft because I'd been burned by it on a number of different PHP platforms at the time. It was never quite clear to me if this was something that was a universal pain or just my own experience. But this is something that we're going to bring up in the context of the core HTTP message signing draft. There's this thing called a specialty type, which basically is one of those flags that signals like, this is the thing that I signed. This might be a new flag for that we could add there. This also doesn't directly protect the content body, which the old draft said, take the body, hash it in SHA-256 and go on with your day. But we can make use of the HTTP digest header, which does exactly that set of functionality. The HTTP digest draft is also in the middle of getting updated. And while I've got some issues with the current state of it, it is moving along well. And okay, so big question, and I'm glad to see Brian's on the call too. And is Daniel? I missed it. But anyway, what about Depop? And I have said this from the beginning with Depop. I think that there is lots of space for these things to coexist. One of the most beautiful things about Depop is that it is very focused on doing what it does and doing it well without getting tied up in a lot of other, what ifs kind of scenarios. And because of that, its simplicity and its deployability is really, really, really great. It is, of course, as a consequence, limited. You can't easily sign headers with Depop defines no way to sign a header as part of the message. You don't even sign the query parameters and paths and things like that. And I think that those limitations are what give it focus. And I think that Depop should be allowed to keep that focus. And the general purpose POP draft that is based on HTTP message signing is where we should be absorbing all of these other use cases. Things like asymmetric keys or AS distributed keys instead of client generated and presented keys. Things like, clients that have a pre-registered key set that the AS just already knows about, as opposed to Depops, like you always present your key. The simplicity of always presenting your key makes a lot of sense for the space Depop is in, and it makes it really simple to always do the same thing. With a general purpose POP thing inside of OAuth, sometimes the client might negotiate a key at runtime. Sometimes it might be pre-registered. We're going to need more flexible language for that kind of thing as we apply this stuff. Another big question is why not? And this gets into Hannes's thing, like why not just use Jose and wrap everything in Jose? The biggest reason here is that Jose is utterly brilliant as a self-contained cryptographic object. This is why it is so good. Oh, yeah, sorry, Hannes. I know you weren't proposing to use Jose, but the question of, what gets wrapped, what gets covered in the questions that we were asking for the old draft. Yep, sorry, I didn't mean to misrepresent there. My bad. But there is a question of why not just use Jose. So this is why, but Jose is really great at self-contained, which is why this is really, really good for things like tokens, for things like assertions and messages, things that you want to be self-contained. An HTTP message object, whether a request or response, it's not self-contained. You've got headers, you've got URLs, you've got bodies, you've got content types, and then that's not even getting into content encoding versus transfer encoding, I think it is. There's lots of weird stuff that happens in HTTP that we all just kind of deal with on a day-to-day basis. HTTP message signatures is designed to live in that space.
Justin, if I can just add something into that as well. This goes back to exactly what we were saying earlier around the if you have an API and you're building a new API and you just want to pack everything into a JOT and that's your API request, and you stick it in the body, you don't care about the rest of the HTTP request, it's just there to get it from point A to point B. Cool, that works. That's awesome. Go do that if that's what you want to do. And then there's this other universe of everything else that's happening over HTTP that doesn't work that way and can't just be like transformed to work that way. And that's really what this is trying to tackle.
Yeah, and we could get into architectural arguments about why one way or the other, but there are a couple of really, really, really important features of HTTP message signatures as of the current draft that are apropos here. One of them, and this one I really, really like, Annabelle and I came up with a way to allow HTTP message signatures to use JWA and JWK for algorithm resolution if you choose to. So if you're already in a Jose kind of world and you've already got, your keys are in JOC format and they've got that alg field and you can already look up all that stuff, then we've actually got instructions that say how to take that and apply that to HTTP message signatures. It's not using JWS data structures with, the headers and the dots and all that stuff. But you can do algorithm resolution using JWA, which is really, really, really powerful. The other thing that you can do, which is really, really neat and important in these multi-tier HTTP systems that we're all building today, is that there's a lot of advanced HTTP stuff that we can now support, such as chained signatures, which is to say, for example, I send a message and it gets dropped onto a reverse proxy. The reverse proxy is in the perfect position to validate all of that, validate the signature because it can look up the key. It has that original message object. It can do all of that, and then it needs to toss that along with someone else. Well, message signatures gives us a way for that intermediary to sign the original signature. So the downstream party can now validate the intermediary signature and know that that incoming message went through the known intermediary. And this is something that it's a really, really amazing security property that a lot of other either message-based systems or point-to-point systems don't really give you, without like massive encapsulation and other kinds of stuff that makes it really, really complex. Such as, for example, you get a JWS object and the payload is another JWS object, which its payload might be a JWE object, and you got to unspiral all of that. These, they live together using, again, that structured header syntax. So that brings us to my last slide. And my suggestion for next steps is that we basically delete the content of the current expired OAuth group signed HTTP request draft and tell it to use HTTP message signatures in the ways that I've been talking about here. The core of it is a relatively short profile. Here's what you have to sign. Here's how you add the token into it, that kind of stuff. But that brings us to a lot of really important questions for the OAuth working group. How do we do key management? For requests to the auth server, we can tie it to a client, but does the resource server need to know now client IDs, or can we do per token lookup or something like that? How do you discover that this feature is available? This kind of token is available. And an interesting one that Annabelle recently brought up is that just like we did with OAuth MTLS, this could actually be used for client authentication as well. A new client authentication type using a message signature as your key proofing. This runs a little bit into the client assertion space, but using a different mechanism. So that's what I had. I'd like to open the queue for questions, discussions, things like that, and figure out where we want to go with this.
Okay, thanks, Justin. So just before we get into that, so I pasted that link again to the chat. Please, if you haven't added your name to the list, go and add your name, because I see we have only 8 people added themselves, while we have about 14 people here. So please go add your name. Any comments, questions from people? I think you can join the queue if you want to use this feature, or add your name to the chat there. We can. Let's try the queue first. I haven't tried it, so.
Yeah, that's the little hand raise icon, I think.
Yes, at the top left there. So, any questions, comments? Any? Join the queue. Okay. Where do I see the queue now?
Looks like Roman's on the queue.
Yeah, but I'm trying to see how I enable him. Yep, a second.
Yeah, I have extra buttons to let myself talk.
Yeah,
Perfect.
Go ahead, Roman. I don't see how I can enable it or kind of allow you. I don't know. Anyway, go ahead.
Yeah, no worries. I just wanted to ask a clarifying question on those next steps. So the thinking is to take that HTTP document and profile a little bit, add some OAuth stuff in the front and back, and we basically assume the constraints of what that draft provides us in terms of the capabilities, and then we say done. Is that roughly the thinking?
Yeah, with the caveats of we need to be able to answer these open questions at the bottom, and that may be within the same document, or it might be within a suite of documents, which was the previous approach. Because we've got the OAuth POP architecture and the OAuth key distribution drafts, neither of which progressed either. But at a very minimal level, yes, we would just say that this is how you take an OAuth token and send it using HTTP message signatures.
Okay, Phil.
Yeah, I just want to say thanks, Justin and Annabelle, as a former contributor to some of those earlier drafts you went through. This addresses a lot of the concerns about how this works and the ones I had with the Cabbage draft. semantic headers, I think is a good breakthrough as well. So yeah, I think we should profile this and work on that, and hopefully HTTP working group gets through finalizing this work. I think this is a big step forward. Thanks.
Thanks,
Thanks,
Phil.
Phil.
Hannes?
Yeah, I'll
Go ahead.
I just wanted to echo that, yeah, there were a lot of issues with the Cabbage draft back in the day, and frustration with that, and seeing so many different splintered versions of that is a large part of why Annabelle and I stepped in to kind of pick this up and pitched it to the HTTP working group, which has been very, very receptive of this.
Yeah,
Okay.
yeah, they've been great. They've provided a lot of good, challenging feedback too, and credit to them. You know, that working group for making structured field values happen, because yeah, that's huge. That's going to be super helpful for this draft. It's going to be super helpful for a whole lot of things moving forward, I think.
Yeah, I have not been this excited about a data structure since JSON web keys.
Okay, good. Hannes?
Can you hear me now again?
Yes, we
Yes,
can.
go ahead.
It keeps asking me about my microphone, so I'm always unsure. But yeah, also as I posted in the chat, yeah, thanks a lot for the work, Justin and Annabelle. This was a frustrating topic that obviously followed us for many years, and I was actually not expecting you guys to come back so soon with this. It looked like a longer endeavor to figure this out, but looks very promising to me.
Yeah. So as Annabelle clarified in chat, you know, this draft isn't done in HTTP. It's still got a ways to go, but we really think that with the last version that we just published, we kind of turned a corner. Like, you guys all know that when you're working on a spec, you hit a point where it feels like a lot of the background churn has kind of settled down. And sure, there's going to be bike shedding of terms and, you know, details of getting this stuff right, especially with the header normalization and all that other stuff. But the basics of it, we feel like it is now in a good place where people can go try out implementing it, try profiling it. Like, this is how it needs to be exercised. So I would expect the OAuth draft to be behind the HTTP draft in the RFC queue by some distance. But I don't think it's going to be many years off. I think we're well on our way.
Okay, awesome. Brian?
I also want to point out, so not to cut off Brian, although I know that's tradition in this working group, Nat was asking in chat how to get into queue as well. I just wanted to make sure we didn't miss him.
Oh.
So while we figure that out, Brian?
Okay. So, okay, go ahead, Brian, and after that, Nat, okay?
Okay, just a couple of very random observations. I am pretty sure that ACE OAuth whatever draft is going to try and register the POP token type. So that might be one more reason to do something else for that.
I didn't know that one. Okay.
I'm like 90% sure. It's not done yet, but I think that's out there. Roberto mentioned to me that they're looking to add a content digest header to the digests draft. I don't know if you've come to that, but that might be worthwhile knowing about, as it may simplify some of the pain and the whole semantics of what is signed and all that. Going back a few slides, you don't need to go back, but the question about whether or not to deal with partial query string signatures, I believe your pain. I think that maybe it's less of an issue these days as fewer and fewer applications are using form encoded parameters that could be in body, could be in the query string, and as the world moves to JSON and beyond, my sense is that's not worth trying to make a special case or exception for. Just a thought. And then just logistically, my feeling would be that this, despite all the similarities and histories, this would probably be better served in a new distinct draft than sort of a complete redo of the previous OAuth sign request. I don't know.
Okay. Yeah, I mean, I'm sorry, go ahead.
No, I don't have a real reason for that other than it feels odd to kind of like drop in a completely new approach over the top of an old approach that has similarities, but is a draft that kind of has been dormant for a while. Yeah.
That's a really great point of whether or not we use that old hanging point, because like I said to Roman, the old draft kind of leaned very heavily on this POP architecture and POP key distribution stuff.
Yeah.
And so that's one of the questions we have to do. It's like, again, one of Depop's brilliances is that it just kind of chucked all that out the window and was just like, no, you're always using asymmetric keys and you're always presenting them, and just deal with it. And so yeah, with this being intentionally a wider thing, those are other questions that we have to answer either in this document, whatever it ends up being, or in a companion document. But it has to be answered.
Yeah, totally agree. But that old, as you said, that old draft defers it to the key distribution draft. And I don't know, I feel like you maybe unnecessarily inherit some of that stuff if you use the same document.
Well, you will have to answer the questions about key distribution irrespectively of it, right?
Oh, absolutely. Absolutely. Just starting anew feels more appropriate, I guess, as well as adoption status and so forth. All right, that's all I got. Thanks.
Yeah. Okay. Thanks, Brian. Anybody else has any comments, questions? Okay. So it seems that there's lots of interest here, and I see people dropping, but raise of hands if you support kind of working on this as a new document, because I'm assuming we don't want to really revive that old document. So let's see, because of this new approach. Raise of hand if you're supporting this document, please.
Rifat, I think the only difference is whether you do a call for adoption, which you would need for a new document, versus already using an existing, namely Justin's working group document, which is still a working group document.
Yeah,
and,
correct. But my understanding is that the mechanism is different from what we've decided to adopt a long time ago, right?
Well, there's so many changes that it isn't unreasonable to do another call for adoption, even if it is a bit of a formality.
Right. Yeah, this is why I wanted to have this meeting instead of just kind of sneakily saying like, hey, there's a new version.
Yeah. Yeah.
But then we don't need to ask the question, right?
Right. So, but functionally, I just want to say, from an editor's perspective, the only thing that would remain would be the URL. Like this is new content.
Yeah, exactly. So okay, Brian is in the queue. Brian, go ahead.
I think Brian was just still in the queue.
No, he's just.
That was a mistake. Sorry.
Oh, okay.
How do I?
Okay. Yeah, no worries.
It's hard to get in and out. Yeah.
Okay. So yeah, if this is the case, I think it makes more sense to call for adoption. I see lots of support here, so we shouldn't be worried about this, in my mind. But I think it's better to go through that process. So, and we still have few people here. Can you please show of hand who supports adopting this as a new work group document? Okay. Okay, awesome.
Should we
So I'm-
understand this as sort of an informal vote, given that
Yeah.
the document?
Oh, yeah,
doesn't
everything
exist?
that you
Exactly.
talked about.
I'm gonna call for adoption on the mailing list for an official one here, just to get a feeling here, right? Okay, good. That's all we have, I think. Any last minute comments, Justin?
No, I'm good. Guys, please take a look at the message signatures draft when you get a chance. It's got a lot of examples and stuff. It'll give you a feel for the structure that we're talking about and how we're looking to use it, the kinds of questions we're going to need to answer.
Awesome.
Right. Thank you all.
all.
And please feel free to
Right.
jump in on the HTTP working group,
Oh, yes,
the
yes.
GitHub issues, and give us feedback on that draft, because that's where that work is happening, and we really want to make sure we're covering all the universe of use cases that's out there.
Awesome.
Yep, completely agree. All right.
Good. Justin and Annabelle, thank you guys for this, and we'll take it to the mailing list. Thank you. Bye.
All right, sounds good. Thank you all.